Crack Calculus Step 2. The Step 1 video, we explain how useful the infinitesimally small number is. It's kind of the real number, and using that we can do pretty neat things. One of the things we can do is to find out the tangent of the curved function. For example, fx, this point x, we take x plus epsilon, then we have fx and fx plus epsilon. Okay, so this tangent, if we make epsilon 0, then this become x plus, and this is gonna be f plus x, right? So we take a ratio. How we take a ratio? F plus minus fx and x plus minus x, right? Okay, so the derivatives definition is going to be epsilon goes 0, we take a limit. Okay, so it's going to be fx plus epsilon minus fx, and limit epsilon 0, x plus epsilon minus x, this disappear. Okay, for if fx is x square, then it's going to be limit epsilon 0, x plus epsilon square minus fx, which is x square, and epsilon. And we expand this, it's going to be x square plus 2 epsilon x plus epsilon square. This disappear, and divided by this disappear, so only 2x left. So answer is 2x. So the derivative function of x square, you can write this way or you can write this way, it doesn't matter, is 2x. Okay, so this 2x is a new function, something like that, and that shows the tangent of fx at the point x. Okay, so that was a review we did so far in the step 1. So the derivative of, how about if fx equals xn? So it's going to be x plus epsilon n minus xn over epsilon 0, right? And this one, you know, are Pascal's. Three, 1, so we know this is gonna get epsilon 0 x to the n plus n x n minus 1 epsilon plus whatever the remaining higher order of epsilon, and divided by epsilon, this one goes to 0, and this one's disappear by this, only remaining is going to be n x n minus 1. So derivative function of this is n x n minus 1. Okay, so if you have n, you put the n in the front and subtract 1. That's going to be derivative function. Okay, so n can be negative. If it's minus 5, you take a derivative, it's going to be minus 5x minus 6. Okay, now we can prove this fx plus another function gx sum of the function, the derivative is going to be derivative of each function. So if you have fx is 3x 2x plus 1, we can take a derivative of this, derivative of this, derivative of those. Okay, and also if you have a constant, fx derivative is going to be constant derivative fx. So this stay there. Okay, and the constant derivative is going to be 0. So using this kind of theorem, let's write up Morse theorem. The product of two functions, derivative is derivative of one function multiplied by this plus, okay, and divisions as well. Derivative is fx minus fx gx square, something like that. Okay, so using those theorem, we can get the derivative function of all kinds of function. Okay, so what's good about the derivative is you get tangent of curved function, and that's very useful method. And the method used is use the infinitesimally small number. Okay, so that's the derivatives. You can write a derivative this way, or dy dx, or f dash x, doesn't matter. Okay, so we will turn this into integral in step 3. So when you go over step 3 video, then you will be pretty much done with calculus. You have a complete understanding of calculus. Remaining is just a practice solving the problem. Okay, so please move to the step 3.